So now that we have a working definition of the derivative, I want to do an example. And so in this example, we're asked to find the derivative of f of x equals 2x squared minus 3x at x equals 4. And what I've done is I've listed below 4 different ways of phrasing this exact problem. So all of these bulleted points here, they are different ways of asking the exact same question. In other words, all of these require the exact same process. So if I say find the derivative of f of x equals 2x squared minus 3x at x equals 4, I could have also asked you to find the instantaneous rate of change of f of x at x equals 4. I could have used different notation. I could have said find f prime of 4, which is just concise notation for the derivative of f of x at x equals 4. I could have said find the slope of the curve at x equals 4. And I could have said find the slope of the tangent line. So those all are asking the exact same question. So that's important to keep in mind so that you don't get confused if this problems are worded a different way. They will often require the exact same process. So let's get into this problem here. So what I'm going to do is I'm just going to remind you, if you haven't seen that last video, which I hope you have, that we have a definition of the derivative. The derivative of a function at a point at an x value, a, is equal to the limit as x goes to a of f of x minus f of a divided by x minus a. Alright, and so in our problem, let's just note that we are finding the derivative at x equals 4. So our a is 4. Our function is f of x. We know that that's clearly 2x squared minus 3x. And so now what we really need to do is just plug in. So f prime of a. So for us that means that f prime of 4 is going to equal the limit as x goes to 4 of f of x. So f of x is 2x squared minus 3x minus f of 4, right? So here I'll write that there for now. We'll calculate that in a second. Divided by x minus 4. Alright, and so what do we have to figure what f of 4 is. Let's go off to the side and do that. So if I plug in 4, that's 2 into our function. 2 times 4 squared minus 3 times 4. So that's 16 times 2 is 32 minus 12 is 20. So I'll just put a 20 right in there. So I'll write it again. So it's equal to the limit as x goes to 4, 2x squared Now here's where you want to know, here's what I want to point out. We have to evaluate this limit, right? We've used the definition and now we're faced with evaluating this limit to get our answer. Now what will always happen is, and this is just by nature of the way we derive this definition up here, you will not be able to plug 4 in right away, okay? Because notice if you do, you'll be dividing by 0. You will not be able to plug 4 in right away. So that's the bad news, because it means we have to do a little bit of work. The good news is, however, is that just by virtue of the way that this definition arose, we are guaranteed that this is going to cancel, that will be able to cancel. So what that means is that numerator we're looking at, I know that that's going to factor, and not only do I know it's going to factor, I know it's going to factor into x minus 4 times something. Okay, that is you need to use that fact to your advantage whenever you're dealing with these problems. So this is the limit as x goes to 4, and I know that numerator is going to factor. It's implicit in this problem. So I'm going to just go ahead and put an x minus 4 there. And then let's see, to get a 2x squared, I think I knew a 2x there. And I think I would need a plus 5 here. So let's just check that that works. That looks good. Okay, so notice this is going to help us deal with the issue of not being able to substitute the 4 in, because now that factor will cancel, so the problem in the denominator is gone. And here I am with the limit as x goes to 4 of 2x plus 5. And now we have no problem just substituting 4 in for x. So it's 2 times 4 plus 5, which is 8 plus 5 is 13. Alright, so at this point, so that was, I mean, there's at some point the calculus ends and it's really just kind of algebra. But let's remind ourselves of what that 13 means, okay? We just found the derivative of f of x at x equals 4. So what does that mean? It means that if I graph my function, and this isn't always necessary, but I do want to make a connection. I'm going to use this grid up here. I'm going to kind of zoom in. Alright, let's graph 2x squared minus 3x. So just very quickly, you can factor out an x, and it's 2x minus 3. So it's a parabola whose zeros are at 0, and looks like 3 halves, 1.5. And it's a parabola that opens up clearly because it has a positive lead coefficient, so it should look something like this, roughly. And so what we found that the derivative was equal to 13. What that means is, it means all of these things. That the slope of the curve at x equals 4 is 13. The slope of the tangent line at x equals 4 is equal to 13. So if we just if we sketch in, and you know what, I need to go in a little bit, I need to go a little farther out, I think, to actually sketch that tangent line. So I'm going to just extend this a little bit. I know it's not quite, doesn't look the best, but hopefully it'll serve the purpose of what I want to do. So at x equals 4, here's x equals 4, the slope of the curve, slope of the tangent line, so I'm going to do my best attempt at a tangent line, the slope of the curve is equal to 13. That's what we found. Okay, the slope of the tangent line is equal to 13. So amidst all that calculation, don't lose sight of what you're actually finding, I guess is my point there. You don't need to make a graph and draw it all the time, but in doing that, it'll just reinforce the calculus behind a lot of the algebra that you compute.